look at this project, which is a race condition. This is the idea. So first we take our Linux machine. I'm using a Linux on ARM machine here. Any kind of Linux will do. So first I have to add a user. We need a low privilege user, so I'm going to call that user noob and give it a password of noob. Oh, I first give it my password to be sudo. Okay, now I do noob. All right. And I don't care about the name and such. I do have to say yes, which is fine. Okay, so now I've created a new user called noob. Now I've got a program here, the race condition, and this is a program which is going to check for some data here and then waste some time and then have time of use. So it's going to have a variable T0 and T1, all right? And then it's going to open a file and try to read the file. And the point is we're going to see it's going to check the security at time T0. All right, anyway, there's a vulnerable time interval between these two things. What's happening is it checks to see if you have permissions to read the file here. But it actually reads the file here, and there's a time delay in between. So if your role is changing, then it can be confused. That's the idea. So now I'm going to do these commands to create this program. I copy race.c to /temp to put it someplace where it can move across user accounts. Now I become root. Okay, and now I compile it as root. And then change it. It's a 4755 race. That makes it, let's do ls-l. That makes it an S file, which means it's owned by root and it will always run as root even though non-root users can execute it. And now I'm going to copy it with the same permissions into noob's home directory and then exit from root. Okay, now I'm going to go and create a file containing secret information in noob's home directory. So as root, using sudo, I'm going to create a file in noob's home directory, and in there I'm going to put secret information and save that. All right, now I'm going to limit access to that file so only root can see it. And you can do that if you do sudo ls-l of home noob. You'll see there it is, secret. It's in noob's directory, but it can only be read by root, not by anybody else. All right, so now we're going to switch to noob. Put in the password. Okay, now cd to go home directory for noob. And there you are. There's a executable file called race here, which is the special SUID file, and then there's secret. So we can cat secret, and we're not allowed to get in there because noob is a low privilege user. They're over here in other, and they're not allowed to access that file. So now we'll create a public file, and in there put public information and save it. All right, and now if I run this race program on public, it shows me what's in there. And if I run it on secret, I don't have access to it because the program runs with root permissions, but the program explicitly checks whether you have read permission before letting you see in the file. Now, the trick is I'm going to create a symbolic link. This creates a symbolic link to the public file. Let's see if I can get this to shut up. Cancel whatever this garbage is. Okay. Right, that'll create a link to the public file called flip. And so if I run race on that, I'm going to see the public information. Now I can overwrite the symbolic link and make it point to secret. And now, when I try to look at it again, now I failed to create it. File exists. Right. So to force it to override, I have to do -SF to force it. Okay. So I do this. That'll force it to point to the secret file, and now I can't get in. Okay. So now what I'm going to do is flip back and forth. So the flip pointer will jump back and forth between the two files. And you can do that with this single line in Bash. It's going to do 1,000, changing it so it points to flip, and then changing it so it points to public over and over and over. So we can count how long this takes and get an idea how fast it's running. Okay, it took about 1 second. All right, so it's going really fast. So now we're just going to make it do that. Instead of 1,000 times, we're going to just do it just going to do it forever. So this is going to do it while true. It's going to do the flipping, and the ampersand at the end is going to run it in the background and give me another command prompt so I can execute more commands here. So it's now flipping, and now I can just run race on flip, and I get the secret information right there. Sometimes I'll get no access, sometimes I'll get secret. You can see sometimes it happens to be pointing, it happens to get it correct that I don't have access. Sometimes it checks the access, and at that moment the flip is pointing to public, so it says yes, you have access, but when I actually read it later, it's changed there. So this is a race condition. All right, and so you can see the CPU information. CPU 26% is being used by this constant process running, and I should be able to kill it. I could kill it by PID 32833. I could also just do FG to bring it to the foreground, and then Control C. That should kill it. And now I should have, yep, no significant CPU is being used except by top, so that ended it. Anyway, that's all I wanted to show you. That's a simple classic example of a race condition. And this happens whenever you check something and then you use it later, and another thread has access to that data and could change it in between those two times. So I'll stop this.